Okay, so Swerve is probably the kind of drive that I know best because it's what we did last year on our Omni robot. And so the idea with Swerve is with some mechanical engineering, you can create kind of a housing for a wheel that will allow it to turn 360 degrees around, and then it will pick a direction and the wheel will spin and drive in that direction. So it is a very complicated drive system to try and use, but the advantage is you get the full power of your drivetrain. And so, as an example for Swerve, if we represent our wheel's velocity vector in polar coordinates, so it has an angle and a magnitude. The thing about Swerve is for each wheel, you need two motors. You need one to drive the wheel forward and another motor to steer it in the direction. So, for driving it forward, it would be really easy. You simply set the drive motor to the magnitude R, or vector. But the steering motor gets a little more complicated because what you want is at the end of the day, you want the wheel to be facing at the angle theta. And so what you need to do is what's called closed loop control. If you put a sensor on the orientation of that wheel so that you know what direction, or you know where it is now, you know where you want it to be, and then you set the motor value so that it's supposed to get there. That's what's called closed loop control. A very common algorithm for doing that is called PID loop. And I don't think I have any other slides on it, but it's a very useful algorithm. Has a lot of applications, not just in doing Omni drive kind of stuff, but a lot of other things on your robot use the PID loop. I would highly recommend you look into it. And yeah, and that's the thing about Swerve especially, is it's so finicky because you have so many things to take care of. You have 4 wheels, you have 2 motors on each wheel, so that's 8 motors. You have to keep track of everything, make sure that none of them are wired up backwards, otherwise it's not going to go anywhere. It's a real pain. Let's just say that. And so what teams will sometimes do is instead of trying to use 2 motors for each Swerve module, they will chain multiple steering or drive motors together. And so you do sacrifice a little bit of mobility sometimes, depending on how you do it. And usually you lose the ability to rotate. And an example of what this happens is in what's called crab drive, which is all 4 of your modules will be chained together so that they're all always facing the same direction. And then you can power all 4 of them together too, so that all of them are always going the same speed. And the result is your robot can move around in any direction you want to, but it can't rotate. And so it's a trade-off because this is a much simpler system, but you can't rotate. And the other example I wanted to talk about, I've heard a lot of names for it. My favorite name is called Warthog Drive because it comes from Halo. I don't know if this is what other people know when they're playing video games, but the Warthog vehicles in Halo, when they turn, it's both axles that actually articulate. And so, for example, this is a top-down view of a Warthog, and if it were turning to the right, both axles would turn like that. And so if you have Swerve modules, you can chain together to get this kind of effect. If you have the 2 in the front steered together and the 2 in the back steered together, then you can angle the front 2 to the right and back to the left, and your robot will turn. So that's sort of a common one. And the nice thing about Warthog Drive is you can also push a button and it will go into crowd mode, where you always have that fallback with almost any Swerve approximation. You can always switch it back into a mode where there's no rotation, but you can move around in any direction. Okay. And I think that's all I wanted to talk about. If you want more information, something that I found really helpful when I was first learning about omnidirectional drives was Ian McKenzie from Team 1114 did a presentation a while back about these kinds of things, and I found it really helpful. And if you have any questions about this, then please feel free to email. Here's my email address. Okay, and any questions? Yeah.
Out of the 3 wheels, which one do you think is the most, like, on last year's game, I guess?
On last year's game? Okay.
Because lots of people use Omni and other people use Canon.
Okay, so the deal with Omni and the Canon is they're nice because they're really easy to work into a drivetrain. Especially the Canon, it's just like an ordinary 4-wheel drive, except you use 4 different gearboxes. And so it's really nice from that perspective because it's easy to use, or easy to build with. Whereas Swerve Drive is very, very complicated, and there are very few times when it's done right. And so, the problem with owning the Canon wheels is you need to be prepared to not push anymore. Because, basically, in order to drive an Omnibot forward, your back 2 wheels will go out, and your front 2 wheels go inward. And so the result is you lose a certain amount of your pushing force. At max, you'll get about 70% efficiency. So that's the trade-off. Swerve Drive is the only one that will let you push as effectively as an equivalent 60. Okay. For last year's game, you can seem to serve some teams well. I thought. Okay. Any other questions or stuff you want to talk about? Okay. That's it, I think. Yeah.